Hello. Let's start CAT 25 target 99 percentile plus. Today we are going to cover algebra functions part 1. Functions is an important topic. Every year you are going to see there is going to be at least one question in the exam, and we need to figure out that how we can approach those kind of questions. Sometimes function can be a lot trickier. Sometimes they are fairly easy. So basically, if you are going to get an easy question and how to get it right quickly, so we are going to focus on that. And second thing is, if you are going to difficult question, how you are going to figure that out and how we are supposed to skip it. So we are going to see various things in functions. Now let's start. So what is a function? So function is anything you write in terms of x. For example, if I say uh, fx. Functions are generally denoted by fx or gx. So if I say fx, so fx is what? Fx is anything that is, let's say, 2x plus 1. That is a function. So if I put some value of x, I'm going to get a respective value of fx. If I put x equal to 2, I'm going to get 5. If I'm going to put x equal to 3, I'm going to get 7. If I could put x equal to 0, I'm going to get 1. So basically, function is made of fx as well as some value of x. Function can also be like this. That is, let's say, x square plus 3. So if x is 0, fx is 3. If x is 1, fx is 4. If x is 2, fx is 7. Right. So I'm just plugging the value of x. Now in function, we are going to see two values, two things. One is called domain. Second is called range. Now, what is domain and what is range? So domain is all the possible values of x that I can put. What is range? All the possible values that I am going to get of fx. So the possible values of x are called as domain. The possible values of fx is called as range. So let's say fx equal to x. That is my function. I'm defining this function. So what is the domain? What are the values of x I can plug in? I can put any value. I can put 1, I can put 2, I can put -1, I can put 0, I can put root 2, I can put any number, right? So what is the domain? So what are the possible values of x? All possible values of x. So domain is going to be a real number. What is the range? Range is also going to be real number because whatever value I'm going to plug in, the same value I'm going to get, right? Now, if I say fx is equal to x square, now, what is the domain? So I can plug in any value of x. X can be 1, 2, 3, 0, -1, 2.5, root 2, root 5. So domain is going to be R. But what are the possible values of fx? Can I say it is going to be negative? If I put x equal to 2, fx is 4. If I put x equal to -2, fx is again going to be 4. So fx can never be negative. Can it be 0? If I plug in x equal to 0, fx will be 0. So it is going to give me all the positive real values, or I would say non-negative real values. So it can be said as r minus r minus, where r denotes real numbers, r minus denotes negative real numbers. So it can be either 0 or it can be positive, or we can write it as r plus means all positive real numbers plus 0. So this is what we are going to get. Okay. Now, if I say fx is equal to root x, then what is going to happen? So again, inside the square root, we can never have a negative number. So it means r plus 0. Because inside square root, there is going to be no negative number. So it is going to be either positive or 0. So this is the domain of this because x can never be negative. So what is the range? Range again, square root of any number is always positive or 0. So it is again going to be r positive plus 0. Now, if I say fx is equal to log x. So if I say fx is equal to log x. So what is the value of x I can have? Can x be negative? Definitely not. Can x be 0? Definitely not. X can be positive? Yes. What is the range? So fx can be positive as well as negative. We have already seen that the value of log can be negative. Uh, Log 1 by 2 base 2 is actually equal to minus 1, that we have already seen in the lecture of log x. So here the range of x, range of y is going to be r, all positive real numbers. So that's how we calculate domain and range. Now, so your job is to figure out that what are the possible values you can put in x, and what are the possible values you can get for fx. So what are the possible values for x are going to be called as domain. What are the possible values of fx are going to be called as range. Okay. Now let's say fx is equal to 2x. What is the value of f of 2? So I can simply plug in that x equal to 2. So it is going to be 2 into 2, or I would say that is 4. Okay. What is the value of f3? That is 2 into 3. Right. We can easily calculate. But if question asks, what is the value of x plus 5? Then what I'm going to do? So it is going to be 2 times. This is x. Instead of x, what do I need? I need x plus 5. So I am going to replace x by x plus 5. So it is going to be 2x plus 10. Right. Now let's take a little something little different. For example, if I say f of x is equal to x square plus 2x, what is the value of f of x minus 3? Okay. So I am going to replace x by 3. So I am going to get x minus 3 whole square plus 2 times x minus 3, and that's what I'm going to get, and solve it, and we are going to get the function for x minus 3. So this is if fx is given and I need to find out the value of x plus a, so this is how we can actually find out the value. Okay. Now if I have something different, for example, if so basically if x is going to x plus 5, so I am going to increase x by 5, so I will be replacing x by x plus 5. Here I am going to have a decrease of 3 in x, so I will be replacing x by x minus 3. So if I have a different type of things, for example, if I have f of x plus 2, and I have that value as x cube minus x square plus 3. And question talks about what is the value of fx. So what is the approach we are going to take? So I have to decrease x plus 2 by 2 so that I can get x. So what I am going to do, I am going to replace x by x minus 2. So it is going to be x minus 2 whole cube minus x minus 2 whole square plus 3, and that's what we are going to get from here. So basically if I want to increase, I will be using x plus 2 from fx to fx plus 5. I want to increase x by 5, so I will be placing x, I will be increasing x by 5. If I am going from x plus 5 to x, then instead of putting x plus 5, I am going to put x minus 5, and I am going to get the value of fx. Now let's take another example. So what is the example we are going to take? For example, if I say that fx minus 1 is equal to x square plus 2x plus 3. Now question says what is the value of fx. So what I am going to do? So here from x minus 1, I want to reach at x. So I am going to replace x by x plus 1. So I am going to get x plus 1. I am increasing it by 1 plus 2 times x plus 1 plus 3, and that's what we are going to get over here. So that's how we are going to solve these kind of questions. Okay. Now there are going to be multiple functions in a question. For example, fx is equal to 2x and gx is equal to x square. Now question says that f of gx, what is f of gx? Or question says what is g of fx? G of fx. So let's calculate both values. So function of gx is equal to x square. So I'm going to replace it by x square. So f of x square. So f of x is 2x and f of x square is going to be 2 times x square. Now g of fx is what? 2x, and it is going to be and what is gx? That is equal to x square. It means I am going to get 2x whole square, or I would say 4 times x square. So these are the values that we are going to get. So 2x square, 4x square, and both values are not equal. So it's not necessary that f of gx will be equal to g of fx. Right, so that's how we are going to get that's how we are going to solve these type of questions. And remember, if question is talking about f of gx, trust me, it's not going to be same as g of fx. You can take couple of more functions from your own end and try to check, and you are going to see that's not true. It might be true in some particular cases, but in most of the cases f of gx will not be equal to g of fx. Now there are a couple of functions that I think that I think you should remember it, that there is this function. This function is always greater equal than 2 if x is positive, and this function is always equal to less than equal to minus 2 if x is negative. So this is a very important point, and this is something that has been used multiple times in CAT. So always take care of it, that x plus 1 upon x, it can be in the multiple formats. For example, I can say that is a plus b by a, and that is always greater equal than 2 if a by b is positive, right? And if it is less than equal to minus 2 if a by b is negative. So these kind of things have been asked multiple times in CAT. So make sure that you do remember all these things. Now let's move on to the questions and see what kind of questions we have received in CAT. Okay. Now the first question is, f1 of x is x square plus 11x plus n, and f2 of x is equal to x, then the largest positive integer n, for which equation f1x equal to f2x has two distinct real roots. Fair enough. So what is the value of f1x? That is x square plus 11x plus n. Okay. What is the value of f2x? That is equal to x itself. So this is what we have, right? So I can say that it is equal to x square plus 10x plus n, and that's equal to 0. So this is what we are going to get. Now we can see it is a quadratic equation, right? So it is a quadratic equation. In a quadratic equation, there is a condition. There are two distinct roots, right? So in quadratic equation, we have three conditions. First is d less than 0. It means there is no real root. Second is d equal to 0. It means only one real root. And d greater than 0. It means there are going to be two distinct real roots. Okay. And what is the value of d? So d is likely defined as b square minus 4ac. Okay. So here I am going to use the third condition, because question is talking about what? Two distinct real roots, right? So basically b square. So what is the value of b? That is minus 10. So b square is going to be 100 minus 4 into a into c. That should be greater than 0. So I can say that 4n should be less than 100. So n should be less than 25. And so it can be any number that is less than 25, but it is talking about largest possible integer. So largest possible integer is going to be n equal to 24. N cannot be greater than 24. If n becomes equal to 25, it means both roots are going to be equal. After that, this distinct condition will not hold true. So that's the reason n should be less than. I'm not taking less than equal to, I'm taking less than. So whenever you see a question in quadratic, so first of all, figure out, compare everything with ax square plus bx plus c. and that's equal to 0, or it is equal to fx. So the coefficient of x is called as a, coefficient of x is called as b, coefficient of constant term is called as c. So fx is equal to ax square plus bx plus c. So a is 1, b is 10. I'm sorry, I have taken it minus 10. It's not minus 10, it's 10. So a is 1, b is 10, and c is n. So in this, d is equal to b square minus 4ac. If roots are real, then d is greater than 0. So whenever in a quadratic function question talks about what are the nature of the roots. Nature of the roots means roots are imaginary, roots are real, roots are equal. So whenever question talks about the nature of roots, the first thing that should click should be the condition on d. D is less than 0 means imaginary roots. D equal to 0 is, it means real and equal. D greater than 0 means distinct roots. So I am using that condition, and from there I am figuring out what is the value of n. Okay. Now let's move on to the next question. What does it says? Okay. So it says that g of f of 3. So I need to figure this value out. Okay. Now, what is the value of fx? So let's go step by step. This question, when you are going to see this question is going to seem extremely tricky, extremely difficult, and it looks a little odd type of question, right? But in reality, this question is extremely easy. And why it is easy? Because I am going to calculate f of 3. Okay. So what is the value of f of 3? So I'm just plugging instead of x, I'm just going to put 3. So 15 plus 2 is going to be 17. Okay. 3 3s are 9. 9 minus 5 is 4. So F3 comes out to be 4. Okay. So I had question of G of F of F of 3. This is the question I had. Now F3 is what? F3 is 17 upon 4, right? So I am just replacing f3 as 17 by 4. So now what I do need to calculate, that is what is the value of f of 17 by 4. So I am replacing x by 17 by 4. So what is the value of f of 17 by 4? Okay. So 17 5s are 85 upon 4 plus 2 upon this is going to be 3 into 17, so 51 by 4 minus 5. This is a little lengthier, but don't worry about it. Take the LCM, so 2 4s are 8 upon 4 upon 51 minus 20 upon 4. Okay, 4 cancels out, so numerator becomes 93, denominator becomes 31. So this value comes out to be 3. Okay. Now I got the value of f of 17 by 4 as 3. So now my question has reduced to g of 3. So what is the value of g of 3? So I'm just, what is the g function? That is x square minus 2x minus 1. So g of 3, I can say that is equal to 3 square, that is 9, 2x, that is 6, minus 1. So this value comes out to be equal to 2. So my answer of this question is going to be option 5. That is 2. So that's how we are going to solve this question. You might say that this question is little lengthier, but definitely not difficult. This question is a must do during the exam. So if you understand the basics of functions, you can easily solve these kind of questions. Now let's move on to the next question. What does it say? Okay, again, this looks very tricky and very odd type of question, like will I be able to do it or not? So let's see what is the approach. So the question is f of, take care of the brackets, f of then gx, okay, uh, gx plus g of f of x. Okay, so basically this total value lies inside the bracket of a function. Okay, now I need to find out all the values at x equal to 1. Okay, so I'm going to figure out what is the value of f1, that is equal to 1, 1 square. What is the value of g1? That is 2 power 1, that is equal to 2. Okay, So what I'm going to do, I'm just going to replace the values f of what is the value of g1, that is 2, plus g of f1, what is the value of f1, that is 1. Okay, that's what we got. Okay, now what I'm going to do, I'm going to calculate the value of f2. So what is the value of f2? F2 is 2 square, that is 4. What is g1? G1 is what? That is equal to 2 power 1. So I would say that is 2. So my final value comes out to be f of 6. Okay. Now, what is f of 6? F of x is x square. So f of 6 is going to be 6 square. So basically it is equal to 6 square. Now, what is the value of 6 square? That is 36. So my answer of this question comes out to be option C. So if you are going to see the question of functions and you are not very comfortable with functions, you might feel that okay, this question is going to be not difficult and trickier. But when you start solving it, you start plugging the values, you are going to realize that these questions are not that difficult. They initially looks scary, but they are not. These kind of questions are fairly easy. Now let's move on to the next question and see and understand what kind of questions we have. Okay. Now this says that f of a into b is equal to f of a into f of b. So f of a into b is equal to f of a into f of b. Now question is saying then the largest possible value of f1. Okay. And there is no other information that is given to us. So what I'm going to do, I am not going to think much. What I'm going to do, I am going to replace a equal to b equal to 1, directly plugging in the values, right? So this becomes f of 1 into 1 is equal to f of 1 into f of 1. So this comes out to be f1 is equal to f1 whole square. Okay. So can I say it is equal to f1 whole square minus f1, and that's equal to 0. So I'm going to take f1 as common and I'm going to say f1 minus 0. Sorry, f1 minus 1. So it is equal to 0. So from here, I can get two values of f1, that is either 0 or 1. Right? There is no other value that is possible for this. So which is the largest possible value of f1? I would say that is equal to 1 itself, because I'm getting only two values. So which is the largest possible value of f1? That is equal to 1, and that's the answer. So again, I would say that whenever you are stuck with these kind of questions, what you're supposed to do, just plug in the values and you are going to get something. So getting these kind of questions is not that difficult. Now let's move on to the next one. Okay. Now, what does this question say? This question seems little trickier, and it actually is. So if I put x equal to 1, right? So if I'm going to put x equal to 1, I'm going to say that f3 is equal to f1 plus f2. Okay. If I put x equal to 2, so f4 is equal to f3 plus f2. Okay. So it means it says that this function of this number is equal to sum of the two previous numbers, right? And that's what question says. Now what I am supposed to calculate, I need to calculate the value of f10. What are the values that are given to us? That is equal to f11 and f15. Okay, so what I'm going to do, I'm directly going to plug in the value of f12. F equal to 10. Okay. So what I am going to get, f of 12, and that is equal to f of 10, the value I need to find out, plus f of 11. Okay. So let's call this value as a that we need to find out, and f11 is 91. So these are the values that we are going to get. Okay. What is the value of f of 13? Can I say it is equal to f12 plus f11? Okay. So what is the value of f12? We have already calculated, that is a plus 91. F11, that is also a plus 90, and that is 91. So I can say it is a plus 182. Okay. What is the value of f14? F14 is equal to F13 plus F12. Okay, what is the value of F13? We have calculated it, A plus 182. F12 is A plus 91. So what I'm going to get, that is equal to 2A plus 273, and that's the value we are going to get. Okay. What is the value of F15? That is equal to F14 plus F13. F14 is 2A plus 273. F13 is A plus 182. Okay, so this is equal to 3A plus 455. And this value in reality is given to us, that is 670. Okay, so 3A comes out to be 162. Okay, so from here I can say that A comes out to be 54. And what is A? A is the value of F10 that we have assumed initially. So I am directly going to get the value of F10, and that is equal to 54, and that's the approach. Now, when you are going to read the question, you are going to think of what I'm going to do, what I'm not going to do, how I'm going to do. So whenever you see these kind of questions in function, just start writing. They might be little lengthier, but they are sure shot. More likely you are going to get the answer. Just be a little patient with these kind of questions, because a lot of times these kind of questions are lengthy. But I won't say that these kind of questions are difficult. They might take some time, 2 minutes, 2.5 minutes, but more likely they are going to give you +3 in the actual exam. Now let's see, let's solve this question. What does it say? For real x, the maximum possible value of this. Okay. So I need to figure out what is the maximum possible value of this. Okay. Okay. Now, let's say I have a term called A upon B. So I can also write it as 1 upon B upon A. A goes to numerator, it becomes A upon B. And that's what I'm going to do, because I have variable upon variable. So instead of going in the format of variable upon variable, I want to go upon constant upon variable. So basically, I am going to write it, it's not 2, it's 4 upon 4x. Okay. So I can write it as inside the square root. So if x gets into the square root, it is going to be square. Okay. So it is going to be 1 plus x power 4 upon x square. So this is the value that I'm going to get. Now what I can say, it is going to be square root of 1 upon x square plus x square. So from here till this point, we have solved this question, and now we don't know what to do, right? So basically, when I have this term and I want to maximize the value, so basically I can say this is a fraction, right? So if this is a fraction and I want to maximize the value, it means my job is to minimize the denominator. So if numerator is constant, then you want to increase the value of fraction, your job is to minimize the denominator. So basically, so how I can minimize the denominator? What is my denominator? That is square root of 1 plus x square plus x square. So I want to minimize it. Okay. We have already seen that x plus 1 upon x is always greater or equal than 2. Okay. Similarly, I can also say that x square plus 1 upon x square will also be greater or equal than 2. Because if I place x equal to 1, so this is going to be 1, this is going to be 1, so this value is going to be greater or equal than 2. So minimum value of this function is going to be 2 only. So if minimum value of the denominator is 2, so what is the maximum value of the function? That is going to be this. So answer of this question comes out to be option B. And what I generally do, I whenever I'm confused with these kind of questions, I just plug in x equal to 1 and see whether any option matches or not. So even if you put x equal to 1, you are going to get your answer. and that's how we are going to approach these kind of questions. So I hope you people are getting a little confidence in functions, because solving a question of function in the exam is not that difficult. Cat does not ask a lot difficult questions. It is the moderate or easy questions are asked for functions, but because the way they are portrayed, they seems difficult, lengthy, so people tend to avoid them. But I think if you practice a little bit of functions, you are going to do extremely great in functions, and in every exam you are going to get one or two questions from functions, and they are doable. With this, I conclude this session. So thank you.